Today we are going to look at the natural base e. E is a number kind of like pi. If I ask you, what does pi equal, what would you say? 3.14. 3.14. 3.14, you know, something around there. But does pi end with 3.14?
No, endless.
No, it keeps going and going and going. It's 3.14159, and it just keeps on going forever and ever and ever. E is another one of those numbers. It was discovered by a guy by the name of Leonhard Euler, spelled E-U-L-E-R. And he was, for some reason, studying the expression 1 plus 1 over n raised to the n. And he was looking at what happens when you use larger and larger numbers of n. So 1 plus 1 divided by 10 raised to the 10th, he got the number 2.59. He did that again. 1 plus 1 divided by 100 raised to the 100th and got 2.7. And he kept doing this with bigger and bigger and bigger numbers until finally he put in a million and he got 2.71. Oh, I forget the exact number. 1 plus 1 over a million raised to the 1 millionth. 2.71828. And it keeps on going. And he noticed that as you approach infinity, you find this ratio E. E is 2.71828, and it keeps on going forever and ever and ever. We basically say E is approximately 2.72. 2.718, 2.72. But because we use this number like a letter, we can use it like a letter, like x. So if I have e to the third times e to the sixth, do you remember what you do with exponents when you're multiplying? Add them. So e to the third times e to the sixth, that would give us e to the ninth. Number 2, first look at the 10 divided by 2. What is 10 divided by 2? 5. And then e to the third divided by an e. If you've got 3 on top, 1 on the bottom, 1 on the bottom will take away 1 of the 3, leaving you with 2 left on the top. Remember with number 3, you need to do 3 squared e to the, anyone want to take a guess what the exponent on e is going to be? Negative 8x. Okay. 3 squared is 9. Do you suppose we can leave our answer like that with negative exponents? No, definitely not. The 9 will stay on top because it doesn't have a negative exponent, and you'll have e to the 8x on the bottom. I would like you to try 4, 5, and 6 on your own. So if you're watching the video, pause the video, try 4, 5, and 6, then play the video. How many times do I have to say pause before you'll actually pause it?
Pause.
Pause?
Pause.
Pause. Hey, you need to pause. Pause it. Okay, and number 4, don't forget, you have 2 to the third e to the negative 15x. So you end up with 8 over e to the 15x. On number 5, you would add those together. 2 plus 4 is 6. 6 plus a negative 3 would be 3. In number 6, the most common mistake here, you get so trained on your properties of exponents, you see division, so you think I'm going to be subtracting. So people try to subtract 8 minus 6. But this is 8 divided by 6. These are not exponents, these are normal numbers. So this is the fraction 8/6, which simplifies to 4/3. So you've got 4 on top and 3 on the bottom. You do subtract the exponents 2x and 3. Can you combine 2x and 3?
No.
No, they are not like terms. So you leave it as 2x minus 3. When it's an expression like that, 2x minus 3, that doesn't count as a negative exponent. It can stay in the top. So that would be your final answer for number 6. You should probably add a number 7. because there might maybe be a problem like this on your homework. Possibly. There is, basically. E squared times e to the 5x. You would add the exponents, but you can't actually combine the 5x and the 2, so you would leave it as e to the 5x plus 2. So just to have that kind of in your notes so that you see it's okay if the exponents don't actually combine. You also need to get familiar with how to enter e in your calculator. So I'm hoping that you all have a graphing calculator in front of you, because we're going to be doing this the most using the graphing calculator. However, you can do this on a scientific calculator if you need to. E is called the natural base. It is connected to the natural log, which the calculator uses ln to describe the natural log. So look for your 4. To the left of 4, you see a button that says ln. That's the natural log. Directly above that, in blue, is e to the x. No matter what calculator you're using, if you can find the ln button, e is the second feature above that. So to do e squared, we will type in second and then that ln button. It will give us e, and it will give us an exponent space. Type 2 and hit enter. E squared is, let's round to the nearest hundredth, 2 places after the decimal. 7.3, close. That'd be if we're rounding to the nearest tenth.
Oh my God.
39. 7.39. We'd be looking at 7.38 or 7.39. The 9 that comes after the 8 bumps it up to 7.39. On your own, try e to the negative 0.06. Did you get approximately 0.94?
Yes.
You now know how to enter e in your calculator.
Thank you.
All right, turn to the next page. We are going to look at graphing. Now here's the thing. I am going to expect you to know how to graph. So we are going to do number 11 completely, finding points, putting them on the graph, talking about the domain and range and asymptote. In number 12, we're going to do exactly what your assignment is going to ask you to do. We're going to graph it in the graphing calculator and then figure out the domain and range just from the picture. So we're not going to completely do number 12, we're just going to look at it in the calculator. So number 11, if we are going to graph something using this calculator, what button do we need to push to enter the equation? Y equals. And let's type in 2 times e to the 0.75x. You don't need the multiplication button, but it certainly doesn't hurt to put it in there. So 2 times, find your e again, second ln, and then in the exponent put 0.75x. If you want to look at the graph, what would you push? Graph. This looks just like exponential growth, or in some cases exponential decay. Exponential growth and decay happen when x is in your exponent. And if you look at this equation, x is in your exponent. E is not something like x. We treat it kind of like x, but remember, e is like pi. It's really just 2.72 approximately. Okay, so if we want to put this on our graph, we need some fairly exact points. So second graph to go into your table. Because e is approximately 2.72, you're going to have a lot of decimals. Which point should we definitely make sure that we graph?
0.2.
0.2. So we are definitely going to graph 0.2. I'm going to pick about 2 points above that and maybe 1 or 2 points below that. So I'm going to use negative 2.4, negative 1, and it was about 0.9. 1, 4.2, and 2, what was it? 8.96, so basically 9. Almost 9. And to graph these, I know it kind of stinks that they're crazy decimals, but we can do it. Negative 2.4, that's like, you know, there-ish, right? Negative 1.9, that's like, you know, almost to 1, so kind of like there-ish. Graphing decimals is fun, isn't it? 0.2, we can definitely get that one pretty precisely. 1, 4.2. And 2, 3, 4, 5, 6, 7, 8, 9. It was almost exactly at 2.9, but just a little under. Now, it might be a good idea to look at your graph again before you draw in your curve, because what do you see along the x-axis? Does the graph cross that x-axis?
Yes.
So there is an asymptote, and you need to make sure when you're drawing yours in that you don't cross that x-axis. Okay, based on this picture, the asymptote is definitely at 0, so we can say that our asymptote is y equals 0. Thankfully, domain and range, it really works the same as exponential growth and decay. The reason that we talk about E in the same chapter as exponential growth and decay is because it is exponential growth and decay. So who wants to guess the domain?
All real numbers.
All real numbers. And the range? Y is greater than 0. Because the points are above the asymptote, you could even draw in a dotted asymptote here to remind you. Because the points are above the asymptote, it's y is greater than. Now, what I want to do in number 12 is type it into the calculator and look at the graph on the calculator. And then all we're going to do is determine the domain and range. On your assignment, the directions say graph the functions using a graphing calculator and then determine the domain and the range. All you have to do is figure out the domain and the range. So go back to y equals and type in e raised to the negative 2x plus 1. Get out of your exponent and then type in minus 3. If you have an older graphing calculator, you would need to type this using parentheses. So here, let me show you what this would look like. Okay, that makes my calculator. So notice it says e raised to the parentheses negative 2x plus 1, close your parentheses, minus 3. So if you have an older calculator that doesn't shove you up into the exponent, that's how you would need to type it. Okay, let's look at the graph. If your graph has grid lines behind the graph, grid lines in the background, it's pretty easy to see that that asymptote is at negative 3. If your calculator doesn't have grid lines, that might not be so easy. But think about that. If the asymptote is at negative 3, what do you see in this equation that could clue you in that the asymptote is going to be at negative 3? This minus 3. So in your notes, you may want to circle that minus 3 and write asymptote. That's going to tell you exactly where the asymptote is going to be. Honestly, you can do the domain without looking at the graph. What's the domain? All real numbers. And then for the range, if you know the asymptote is negative 3, you know the range is going to be y something negative 3. Now look at the graph. Are the points above that asymptote or below? Above, so y is greater than. And that's all you have to do on your assignment is graph it, look at the picture on your calculator. What's the domain always going to be? All real numbers. And then the range, look for where the asymptote is, look at the equation to help you with that, and then decide greater than or less than.